This video lesson carries on from the previous one on the properties of water to look at some further properties of water and also their applications to animal life. Here are the objectives. Now remember, in the previous video lesson we looked at the structure of the water molecule, and we said that because this is a polar covalent bond, the water molecule itself ends up being polar, and a lot of water's properties come from hydrogen bonding between the hydrogen of one water molecule and the oxygen of the next. Hydrogen bonding is a particularly strong kind of intermolecular bonding and gives water a lot of its properties. We also talked about how like dissolves like. Water dissolves other polar molecules. Now let's add some language to that. We can use these terms hydrophilic, hydrophobic, and amphipathic to talk about how molecules interact with water. So hydrophilic means water-loving, and this refers to polar or charged molecules or ions, and they interact with either the negative oxygen or the positive hydrogen of water, and therefore they will be dissolved well. Examples would be things like table salt sodium chloride or glucose. Sodium chloride dissolves into ions, and glucose is a polar molecule, and therefore they will be attracted to the positives and negatives on the water and will dissolve well. We call those hydrophilic, meaning water-loving. Hydrophobic literally means water-fearing or water-hating, and these are molecules that are nonpolar and therefore don't interact well with the partially negative and partially positive oxygen and hydrogen on the water molecule. Examples of these would be a hydrocarbon chain of just carbons and hydrogens, and it's not going to dissolve well in water. And a molecule that has both hydrophilic and hydrophobic parts, I'm going to just write these arrows to avoid rewriting it. A molecule that has both hydrophilic and hydrophobic parts in different parts of it is called amphipathic, or sometimes you'll also see it written as amphiphilic. They mean the same thing. And an example of that would be a phospholipid, which makes up the cell membrane or the plasma membrane. The phosphate head is hydrophilic, the lipid tail is hydrophobic. Soaps are another example. In fact, that's how soaps work. Part of them can dissolve in water, and part of them can dissolve in grease, and that's what allows them to help us get grease off of our plates by rinsing them in water. So hydrophilic means water-loving, hydrophobic water-fearing, and amphipathic has parts of both. Now let's look at some other properties of water, starting with buoyancy. So buoyancy refers to the upward force of a fluid on an object, and it's equal to the weight of the fluid that's displaced, and so as a result it depends on the density of the fluid that's displaced. A denser fluid leads to a greater upward force. Now both water and air are fluids, but water is much more dense than air is, and so there is an upwards buoyant force from both water and air on anything in them. You might not think of that with air, but that's how balloons can float. A helium balloon floats because helium is less dense than air, and the air provides an upwards buoyant force. Both water and air provide upward buoyant forces, but the water provides a much greater buoyant force because it's much denser. A consequence of that is that aquatic mammals can get very large. So think of a whale. It is a very large aquatic mammal, and if it were on land, the downward force of gravity would potentially crush it under its own weight. But because it's supported by a large buoyant force from water, as opposed to the lesser buoyant force from air, it can survive in water when it wouldn't survive on land. Another consequence of buoyancy that we should think about is the way that ice floats. Ice is less dense than liquid water, and as a result, when water freezes into the solid form of ice, it floats on liquid water. And so if you have a body of water like this, the ice will float on the top, and the water underneath will remain liquid. And that's important because that means that life can continue down here. Life can continue moving and surviving in the liquid part that's underneath, even when the top freezes over. If water in its solid form of ice were more dense, then the whole thing would freeze from the bottom up, and then you would not be able to have movement and life below. Now let's look at thermal conductivity. This refers to how fast heat is transferred by a material, and water's thermal conductivity is higher than air's, and that leads to faster heat transfer. And this is again a consequence of the greater density of water when compared to air. To transfer heat energy, molecules need to bump into each other, and that happens more easily and faster when they are closer together as they are in water compared to air. So water has a much higher thermal conductivity than air, transfers heat faster. And in general, animal bodies are warmer than their surroundings, and so they will tend to lose heat to their surroundings. And so animals in water will tend to lose body heat to surrounding water very quickly, and therefore need mechanisms to protect against that so that they don't lose a dangerous amount of body heat. So aquatic birds will trap air in their feathers. Feathers, one of their functions besides flight is that they trap air in them, and because air's thermal conductivity is not as high as water's, that means that trapped air serves as an insulating layer. The other thing that aquatic birds do with their feathers is they often oil them. Oil is hydrophobic, keeps water out, and therefore protects against loss of heat to water. Now, in contrast, sometimes an animal might want to lose heat, and it can do that, it can cool by circulating blood. Blood, of course, is mostly water, and therefore will carry a lot of heat away due to water's high thermal conductivity. So elephant ears are large not because of anything to do with hearing, but because the large elephant ears, when blood is pumped throughout them, can carry heat away from the core of the body so that it can be lost to the environment to prevent the elephant from overheating. Last, let's look at viscosity. This refers to how easily fluid flows. And the hydrogen bonds in water increase its viscosity compared to other liquids, and therefore moving through water is rather difficult, and animals that need to do that are aided by having a streamlined or hydrodynamic shape. And this is more important for animals that move through water compared to animals that move through air, which is less viscous. So that's a look at some further properties of water and how they apply to animal life.